Have you ever wondered just how complex the game of chess really is? We all know it's a game of deep strategy, but the true scale of its complexity is mind-boggling. Prepare to have your mind blown because we're about to dive into a number that's almost too big to comprehend. Let's start with a simple question. How many different ways can a game of chess unfold? Take a guess. A million, a billion, maybe a trillion? All of those are laughably small. The real number is so vast, it makes astronomical figures look like pocket change. This incredible number is called the Shannon number, named after the brilliant mathematician and father of information theory, Claude Shannon. Back in the 1950s, he sat down and did the math to estimate the game tree complexity of chess. He wasn't trying to find the exact number of all possible legal games, but rather a conservative lower bound, estimate of the number of sensible, different games that could be played. His calculation resulted in a number that is 10 to the power of 120. Let me try to put that into perspective for you. It's a 1 followed by 120 zeros. If you tried to write this number out, you'd be writing zeros for a very, very long time. This number is so large, it doesn't even have a common name, like a billion or a trillion. It's just 10 to the 120. Now let us compare this to something else that we consider unimaginably vast, the number of atoms in the known observable universe. Scientists estimate this number to be somewhere between 10 to the power of 78 and 10 to the power of 82. Let's be generous and take the high end 10 to the 82nd power. That's a 1 with 82 zeros after it. A colossal number, right? Well, the Shannon number, representing the possible iterations of chess, is a 1 with 120 zeros. This means there are more possible, unique games of chess than there are atoms in the entire universe. Think about that for a second. Every star, every planet, every person, every single grain of sand on every beach on Earth, add up all the atoms that make up everything we can see. And that total number is still smaller than the number of ways a single game of chess can be played. It's completely staggering. So how did Shannon arrive at this figure? It wasn't a random guess. He made a few reasonable assumptions. He estimated that in a typical chess position, a player has about 30 possible moves to choose from. He then estimated that an average game of chess lasts for about 40 moves, meaning 40 pairs of turns, one for white and one for black. So, the calculation goes something like this. For the first move, you have roughly 30 choices. For the second move, your opponent also has about 30 choices. For your next move, another 30 choices, and so on. To get the total number of game variations, you would multiply 30 by itself 80 times, once for each of the 40 pairs of moves. However, because the number of choices changes throughout the game, he simplified it by taking an average. So, you have an average of about 30 choices per turn, over an average of 80 turns in a game. He actually refined it a bit. He looked at it as 30 choices for white and 30 for black for 40 full move cycles. So, 30 times 30, which is 900, raised to the power of 40. A more simplified version is to say, there's an average of about 30 choices available for each of the 80 individual moves. The math gets a little complex, but it consistently points to this enormous figure. The core idea is exponential growth. Every single move opens up a new branching path of possibilities, and these branches multiply at an astonishing rate. Now, you might be thinking, wait a minute, not all of those games are logical. Some of them would be just random, silly moves, and you'd be absolutely right. Shannon's number is an estimate of the game tree complexity, not necessarily the number of perfect or even good games. It includes all sorts of blunders and strange sequences. However, another mathematician, Victor Alice, went even further. He calculated a more precise upper bound for the number of legal chess positions, which is around 10 to the power of 46. This number is smaller, but it's still astronomically large. And when he estimated the total number of possible legal game paths, his number was even bigger than Shannon's, reaching at least 10 to the power of 123. So, Shannon's famous number is actually quite a conservative estimate. What does this all mean in practical terms? It means that chess is, for all intents and purposes, an infinite game for humans. Even with the most powerful supercomputers we can build, we will never solve chess. Solving chess would mean finding a perfect strategy from the very first move that guarantees a win or a draw, no matter what the opponent does. Think about computers like Deep Blue, which famously beat Garry Kasparov in 1997, or modern engines like Stockfish and AlphaZero. They are incredibly powerful, capable of calculating millions, even billions of positions per second. But even they don't play by looking at every single possible outcome of the game. It's simply impossible. Instead, these chess engines use clever algorithms and evaluation functions. They look ahead a certain number of moves, maybe 20, 30, or even more, and then they evaluate the resulting board position. They assign a score based on factors like material advantage, piece activity, king safety, and positional control. They then choose the move that leads to the best possible score down their calculated line of play. They are essentially making a highly educated guess about the best path forward, not mapping out the entire game. The sheer vastness of chess is what makes it so beautiful and endlessly fascinating. It's a universe contained within just 64 squares. Every single game you play is almost certainly a game that has never been played before in the entire history of humanity. When you make your opening move, you are embarking on a unique journey through this immense cosmic web of possibilities. This complexity is why chess has captivated minds for over 1,500 years. It's a game that you can spend a lifetime studying and still only scratch the surface. There will always be new ideas, new strategies, and new beautiful combinations to discover. No one will ever master it completely. Not me, not you, not the greatest grandmasters, and not even the most powerful supercomputers of the future. The game is a testament to the power of simple rules creating emergent, seemingly infinite complexity. Just a few types of pieces, each with its own simple way of moving, on a small 8x8 grid, gives rise to a level of complexity that dwarfs the physical universe. So the next time you sit down for a game of chess, whether it's online or with a friend over a physical board, take a moment to appreciate the incredible depth of what you're doing. You're not just playing a game. You're navigating a tiny fraction of a possibility space larger than the cosmos itself. Each move is a choice that carves a unique path through this unfathomable landscape. And that, I think, is a truly beautiful and humbling thought. Thank you so much for watching. If you found this as mind-blowing as I did, hit that like button and subscribe for more deep dives into the fascinating world around us. What other game or concept has a complexity that just amazes you? Let me know in the comments below.